So first thing, let's talk about gas liquid chromatography.
ये जो क्रोमेटोग्राफी की जो लेक्चर है आप रिकॉर्ड करेंगे, अपलोड करेंगे?
हाँ, ये मैं कर दूंगा, ठीक है।
ओके।
अच्छा, चलो फर्स्ट थिंग, गैस लिक्विड क्रोमेटोग्राफी। इसका सिंपल ये कि बहुत ज्यादा रिक्वायर्ड भी नहीं है, बिल्कुल बेसिक सा नॉलेज होना चाहिए। इसकी एक पिक्चर में कहीं से ढूंढ लूं। गैस लिक्विड, आई मीन डायग्राम इज नॉट इम्पोर्टेंट एज वेल। गैस लिक्विड, so just a basic diagram, ठीक है। नहीं, इतना सही नहीं है। Just 1 second, let me. चलो, I'll draw a diagram myself, or explain भी कर देता हूँ, and just over here कि what is required. Then there gas liquid. As I described, understand stationary phase, high boiling point, non-polar liquid, non-polar liquid on a solid support. Mobile phase, unreactive gas, retention time. Interpret I explain retention terms in terms of interaction with the stationary phase. So now this is what happens in where's my board? I said this is what happens in a gas liquid chromatography. Okay, you have, let's say you have these tubes. Okay, so let me. Okay, there's going to be long cylindrical tubes that would be coiled up. Okay, so that's one. So here's another one. Okay, and it's going to be a long cylindrical tube. So here's another one. अब होगा ये कि the tubes are obviously connected together. So they're all connected together. Now, at one end, you have a mobile phase, which is an unreactive gas. So you've got an inert gas. Usually, it's a noble gas.
So nitrogen भी हो सकता है.
हाँ, ठीक है. Any unreactive gas, ठीक है. Helium, nitrogen, etc. So it's an inert gas. That's a mobile phase. As a mobile phase in chromatography is the phase that moves. Okay, that's a mobile phase, and a sample is injected into the mobile phase. Okay, the mobile phase carries that sample. A vaporized mixture is put into the mobile phase. So you've got so you're going to get a vaporized mixture, and let's say that mixture contains two things. It contains X and Y, and maybe it contains 3 substances, 4 substances, whatever. Okay, and in these tubes you will have as in these tubes over here, they're going to be lined with a high boiling point. So they're lined with a high boiling point stationary phase. ठीक है, so that is और यहाँ पे मैं देख लेता हूँ एक second. So कहाँ पे है syllabus? So it's a high boiling point non-polar liquid on solid support. So this over here is your stationary phase. So it's a high boiling point. As a high boiling point, you don't want it to evaporate. So high boiling point, and it's non-polar as well. And that's basically your stationary phase. So now what's going to happen is, okay, as the particles travel, okay, there's a mixture of X and Y, and as the particles travel, और इसको अगर थोड़ा सा बड़ा करके ड्रॉ कर लो कि if I just इसको थोड़ा zoom in कर लें and I show you a section of the tube. And now this is what's going to happen. Okay, there's a mixture of X and Y, and that is traveling. So you've got all these particles of X and particles of Y that are mixed together. Okay, let's say it's a dye, it's a vaporized dye, and they are mixed together. And in the tube, there is this non-polar high boiling point, stationary phase. अब होगा ये कि as the particles are moving, as the particles they move, so one of the dyes would be more soluble in the stationary phase. So what will happen is, okay, let's say the green particles are more soluble. So the green particles would start to get absorbed, or they would start dissolving in this stationary phase.
Stationary phase.
Or again, if they dissolve in the stationary phase, they're going to stop moving. The red particles would keep on traveling. Okay, they're going to keep on traveling, while the green ones would slow down. Okay, and maybe after some time, the green particles will slow down. After a certain time, the green particles would evaporate again, and they would start moving again. But the point is, if they are more soluble in the stationary phase, they would continue to slow down every time. Okay, थोड़ी देर बाद they would evaporate. But so this is how separation is happening. Idea clear? Is this clear? ठीक है, तो separation. See the explanation, and a separation happens. Why does it happen? Because there's a difference in solubility. So due to difference in solubility of the mixture or of the component, or the dye between stationary and mobile phase. And mobile phase. So that's about it. Okay, is this clear? You clear?
Yes, sir.
और अगला पार्ट ये कि so how would the results be obtained? So what you're going to get on the other side is the output. Over here, there's going to be a graph that's going to look like this. Okay, it's going to look like this. Okay, at the very beginning, you'll have a big spike. Okay, the first thing that you'll obtain is going to be the stationary phase. It's going to be the liquid. Okay, the first thing that you'll get is, the liquid would be seeping out. So is tubes going to liquid, that's going to be seeping out. So that's the first thing that you'll obtain. After some time, maybe X reaches first. So if X reaches first, so you're going to get X at the other end. And after a certain while, you're going to get Y. Or यहाँ पे ना, the axis represents time. And there's going to be a retention time. If something is obtained earlier, it's going to have a lower retention time. And if something is obtained much later, that's going to have a much higher retention time. Okay, so is this clear?
Sir, जो later obtain होगा उसका high retention time होगा.
हाँ, क्योंकि टाइम ज्यादा है ना बेसिकली. जैसे वो RF होता था, RF वैल्यू, उसमें रिटेंशन फैक्टर होता है, इसमें रिटेंशन टाइम होता है. If something doesn't dissolve in the stationary phase, it just moves very quickly in the tubes, so it will immediately be obtained at the other end, and it will be detected by the detector. ठीक है. अब area जो in curves का है ना, the area represents वो the amount of the substance. So you can, by looking at the area, you can tell okay, which one is more, X or is it Y. Okay, that's about it. So clear है?
जी सर.
और मतलब इसमें I'll just add कि if there is high retention time, so that means the substance is soluble in the stationary phase or is more soluble in the stationary phase.
सर क्योंकि ये देर से डिटेक्ट होता है.
हाँ, क्योंकि वो पीछे स्टेशनरी फेज मतलब वो बार बार उसके अंदर मिक्स हो जा रहा है ना, तो इज मोर सॉलेबल in the stationary phase. So that's it. Or I'll just do a question on this. Let me just find one question. Oh, basics are question over just a second. Okay, gas. अच्छा और कोई इसका डिटेल इंपॉर्टेंट नहीं है, ठीक है. अच्छा एक वीडियो भी है उसकी, ये देख लेना जाके. अच्छा नहीं भाई नहीं रहा, एक सेकंड. अच्छा paper chromatography is no longer, I didn't find it. Yes, syllabus देख लेना, but paper chromatography is not really there. Yeah. That's okay. Paper chromatography and gas liquid chromatography both rely on the partition of compounds between mobile and stationary phase. Identify the paper chromatography. Suggest what type of liquid is used for the stationary phase in a gas. What type of liquid? It's a high boiling point liquid and it's non-polar. ठीक है, मतलब syllabus में लिखा हुआ. Both these techniques can be used to separate mixtures. State what you would measure in order to distinguish between the components. Gas liquid chromatography is all about retention time. ठीक है, clear? तो इधर मैं ऐड कर दूं कि यहाँ पे you'll be measuring retention time. अच्छा और क्या कि let me find another question. हाँ ये वाला, ये वो diagram given, a gas chromatogram is given, and an alkene, a carboxylic acid, and a ketone of similar volatility are mixed together. Similar volatility का मतलब है कि separation is not based on volatility. I mean, they're going to evaporate at the same rate. So the separation of the three compounds depends on the relative solubility in the liquids in the stationary phase. The liquid stationary phase is an alkane. So it's a non-polar. It's a non-polar alkane. So that's the liquid, ठीक है. तो अब इनमें से बताओ कि which one is going to be more soluble in the alkane? Alkene, carboxylic acid, or ketone?
सर alkene क्योंकि वो नॉन पोलर होगा.
ठीक है, तो alkene जो है ना, that's going to be taking the longest. L is alkene. Is that clear? और वो कौन सा जो dissolve ही नहीं होगा, carboxylic acid forms hydrogen bonds, ठीक है, so it will not be interested in the alkane. So this would be carboxylic acid क्योंकि it's highly polar. और फिर K रह जाता है, that's the ketone. Is this clear?
So मतलब carboxylic acids are more polar than ketones.
हाँ क्योंकि उसमें OH है ना.
Oh yes.
ठीक है, बस वही है, बाकी है कि वही explanation उसने कहा, वो देख लेना, 2 marks का question, that's about it. And the area is given, उसने कहा the area underneath each peak is proportional to the mass. The percentage responsible, बस वो percentage of K निकालना है. Yeah, so this is the total mixture. So what is the percentage of K? It's going to be 18 divided by the whole thing, which is 46 plus 18 plus 28. into 100, ठीक है, so you'll get the percentage, ठीक है, बस ये, इसके अलावा कुछ नहीं है. So is this clear?
Yes.
अच्छा फिर कहाँ पे जो दूसरे syllabus जी sorry syllabus एक second. अच्छा ये वाला thin layer chromatography, अच्छा ये exactly ना उसी तरह है. RF values, it's paper chromatography जो basically थी जो वो levels में थी, it's exactly the same. इधर वो कह रहे stationary phase, but it's exactly the same except कि वो उसके अंदर मैं थोड़ा सा explain कर देता हूँ इसको थोड़ा सा, ठीक है. तो thin layer chromatography is kind of the same as your O levels chromatography. ठीक है, तो अच्छा thin layer chromatography में क्या होगा कि you'll have usually a metal इसको vertical draw कर लेते हैं. अच्छा it's usually a metallic plate और उसके ऊपर ना there's aluminium oxide, ठीक है. So there's an aluminium oxide usually in the form of a gel that's coated on it, ठीक है, that's placed on it on a solid support. That's your stationary phase, ठीक है, that doesn't move. अच्छा उसके बाद what you do is you have a mobile phase. So there's a liquid that carries the mixture. There's a mobile phase, and that can be any liquid. So it could be any polar or even non-polar liquid. इसमें ये कि it could be any polar non-polar liquid, and it's a mobile phase, plus it will contain the mixture as well, whatever that mixture is. Let's say it's got particles of X and particles of Y. Achha, what will happen is there's going to be a concept called adsorption now. Ki red particles, if they're traveling and they don't get attracted to the aluminum oxide layer that's at the bottom, so the particles would continue to travel along with the solvent, with the mobile phase. But ye jo green wale, if they start bonding with or they get attracted to the aluminum oxide gel, so they would stop. So this is known as adsorption. Adsorption उसमें भी था कि they form weak bonds. So if a substance, जिसमें होगा कि if a substance forms weak bonds with the stationary phase or gets attracted to the stationary phase, then it will slow down.
मतलब हमारे मिक्सचर में जो भी चीज ज्यादा सॉल्युबल होगी इन द स्टेशनरी फेज वो एब्जॉर्ब होगी.
नहीं इधर solubility का नहीं है, इधर bonding का है. कि मैं कह रहा हूँ bonding इस तरह ना कि assume करो कि let's say you have जो भी चीज है उसके साथ attract हो रही होगी. इधर solubility नहीं है, it's a gel. तो anything that gets attracted or binds with the gel वो फिर रुक जाएगी, जो नहीं bind करेगी that will continue to move further on. ठीक है, ऐसा क्या?
Yes, sir.
तो उसका thin layer chromatography create a diagram. ठीक है, ये तो उन्होंने बिल्कुल वैसे ही बनाया हुआ है, इसको कॉपी भी कर लेते हैं. अच्छा, that's basically your O level stuff. So if somebody is going to ask you to calculate RF values, it's exactly the same. But remember, it's different because it's not paper chromatography. Paper chromatography was different. इसका जो पीछे concept है ना वो different है. कि यहाँ पे it's a gel, it's a thin layer chromatography plate. इसके ऊपर there's a gel and the solvent is passing through it. और वो spot of mixture लगा हुआ है, ठीक है. और यहाँ पे you're going to calculate RF values. So what were RF values? It's the distance that is traveled by the solvent divided by the distance that is traveled by the dye. ठीक है, ये तो याद रहे क्या होती है RF value. तो distance of dye और mixture और उसको डिवाइड कर देना distance of
solvent front.
अच्छा, distance of solvents है. So that is RF value. इसका क्वेश्चन देख, इसका क्वेश्चन तो बहुत ही ले रहा है. Thin, पता नहीं, मैंने तो बहुत ही कम देखा है इसका क्वेश्चन. So even one question, that's 2019. Exactly वही O levels वाला question है. RF values given है. So all you have to do is के match करो RF value, measure करो. So you can do that. Solvent front. Remember baseline से start होता है सब कुछ 0 to. So amino acid responsible for spot A. Add के RF value calculator, you'll find the and then match the RF value. Here's second chromatogram of the same mixture is taken using a more polar solvent. Predict the effect on RF value of amino acids. Achha, so remember, amino acids are polar as well. So if it's a more polar solvent, the amino acids will travel a lot lesser distance. Okay, sorry, the solvent is more polar. So the amino acid would remain dissolved in the solvent. Is that clear? And they would travel a larger distance. ये बात समझिए कि अगर more polar होगा तो amino acids are polar, so they would remain part of the solvent, ठीक है? तो वो stasy phase में नहीं जाएंगे. They will continue to move with the polar solvent. So RF values would be much larger. इसकी reasoning, it's just one mark. You explain the reasoning, so you'll do that, ठीक है? So that's kind of about it. इससे ज़्यादा मुश्किल question नहीं होगा, ठीक है? चलो ठीक है, ये भी
ज़्यादा travel करती है, वो ज़्यादा soluble होती है in the mobile phase.
हाँ, मतलब वो उसका क्रोमेटोग्राफी में है ही है कि मोबाइल फेज में अमाइनो एसिड्स आर पोलर और आपका सॉल्वेंट भी पोलर है, जिसका मतलब है कि आपका जो अमाइनो एसिड है इट्स मोर लाइकली टू रिमेन पार्ट ऑफ द सॉल्वेंट, राइट? So it will continue to move with the solvent क्योंकि वो सॉल्वेंट से ज्यादा अट्रैक्ट हो रहा होगा एंड तो इसलिए वो ज्यादा ट्रैवल करेगा. जो चीज मोबाइल फेज में रहेगी वो फिर ज्यादा ट्रैवल करेगी, जो स्टेशनरी फेज में चली जाएगी वो कम ट्रैवल करेगी, ठीक है? सो इज दिस क्लियर? तो बस ये इसमें बाकी तो कोई चीज नहीं है, बस 2-3 छोटी मोटी चीजें थी वो भी होगी. चलिए ठीक है, ये फिर कल कर लेते हैं. वैसे अब खत्म हो गया, कोई और नई चीज नहीं पढ़नी, क्वेश्चंस बस लेके आना, ठीक है? चलिए,
थैंक यू सर. अल्लाह हाफिज़.